First of all, see what we're looking at. We've got a nice pretty sine wave that is roughly 132 volts peak to peak at about 290 kilohertz frequency. That's the output from a induction oscillator. This is the L, that's the C of the oscillator. There's some other components. That's the initial inductor to prevent like initial inrush current. This is only a few turns of wire on the output coil, and the primary coil. The secondary coil is just a single loop, and it's 14 gauge wire, about 7 inches long, with an LED across the middle of it. And so by putting it in proximity, you see how bright that comes on. I mean, it's fairly bright. That's all there is to it. Put a piece of paper on there, a piece of paper over the top of it here, and let's see if I can find it. There we go. So that's just 7 inches of 14 gauge wire with an LED going pretty bright on it. The idea for this was to use maybe some Christmas lights to mount this structure in a wreath. Make a large ring in the wreath that's picking up the power and powering lights within the wreath without having to run wire. So you could essentially power it from one side of a window and stick a wreath on the other side of the window to power the lights inductively, but without having to do like a whole bunch of turns of wire, obviously. So that's pretty slick, actually. It's anyway. So that 130 volts that's measuring is what's measured across the actual primary coil. So that coil, the length of the wire on that's 14 gauge also, but it's about 4.5 feet long, coiled around a 2-inch PVC pipe. Is how I got the form. Same for the single turn on this. So if you think about that, if you got 130 volts going through 4.5 feet of wire, that resistively, if you measure that, is just a couple ohms of resistance, and even less with just a single turn of 14 gauge wire. You think of that from a current perspective to see how much power is actually going through there. It's pretty amazing, actually, that this even lights at all. But what it also says is that the output here is fairly high current, so you could drive several of these lights off of a single coil without any problem at all. There's plenty of power there to be able to do that, and there's no tricks or anything like that. It's just it's primary coil is the red that you see, and the secondary coil is the silver exposed. It's actually a piece of electric fence wire that is just cut to like 7 inches long. So anyway, that's the idea. I just thought this was cool to demonstrate, because I mean, you think about something like this and you think, oh well, there isn't possibly enough voltage in that amount of wire to do anything with. Well, that's proving that wrong. So just kind of rethink outside the box a little bit next time you have a project that you need to you don't realize how much voltage is across a wire, especially when it's a resonant frequency. That's the key, is that this is a resonant tank circuit between the L and the C over here. So if you're not energizing that at resonant frequency, then it's not going to do hardly anything. But once you get it at resonant frequency, it's orders of magnitude as far as the voltage. This is just a simple heat sink, and it's cool to the touch. So anyway, that's all for now. Thanks. Bye.